Hi students, myself Kale SL, Rayat Shikshan Sanstha's RBNB College Rampur. 12th Science Mathematics Part 2, Lecture number 24, Indefinite Integration, Exercise 3.4. In the previous lecture, we start integration by partial fraction and we have completed 15 problems. There is only one question. Question first, integrate the following functions with respect to x, and there are totally 23 problems we discuss here, 15 problems. Now here we start next problem, problem number 16, integration of 1 upon x cube minus 1 dx, call this as I. So I is equal to integration of 1 upon x cube minus 1 dx. So this is equal to integration of 1 upon x cube minus 1 cube dx. So this is equal to integration of 1 upon x minus 1. We factor this x cube minus 1 cube using the formula a cube minus b cube. A cube minus b cube is equal to, in first bracket, a minus b, and in the second bracket, a square plus ab plus b square. We use this formula and factor this. So in the denominator, here x cube minus 1 cube, so x minus 1, and in second bracket, x square plus x into 1, that is x, and plus 1 square, it is 1, and dx. And now observe here denominator. In the denominator, there is one linear factor and another one is quadratic factor. Means this rational function is of the third type. That is product of linear factor and non-repeated quadratic factor. So here consider, let 1 upon x minus 1 into x square plus x plus 1, it is equal to a upon first factor x minus 1 and plus, in the denominator here write this quadratic factor, that is x square plus x plus 1. In numerator we write bx plus c. And now here take the addition of the right hand side. Make the denominator of this first term as x minus 1 into x square plus x plus 1. So we multiply numerator and denominator by this x square plus x plus 1, and to this numerator and denominator by x minus 1. And so we get here a into this denominator x square plus x plus 1 plus this numerator bx plus c into this x minus 1. And here left side is 1. Both the denominators are same, we cancel that. And now we want to find these unknowns a, b, c. So put here first factor. Put here first factor means suppose x minus 1 is equal to 0, that is x is equal to 1 in this equation. And therefore we get here 1 is equal to a, x is here 1, so 1 square plus 1 plus 1, that is 3, and plus here x minus 1 0, so 0 into this, that is equal to 0, and therefore we get here, this implies that a is equal to, carry this 3, so a is equal to 1 upon 3. In this way we get the value of a. Now we want to find here unknown b and c, and here linear factor is only 1, so we take that as x minus 1 is equal to 0, and we get one unknown. Now how to find remaining unknown? We take the values of x on the real line by trial and error method. We may take here 0, minus 1, minus 2, or 1, 2, 3, etc. So here if we take x is equal to 0, this b will get cancelled. So take here x is equal to 0. Put here x is equal to 0, and therefore this equation becomes 1 is equal to a x is 0, so 0 square, that is 0 plus 1, so a into 1, then plus b plus in the bracket b into 0, that is 0, plus c, so 0 plus c, and x minus 1, x is 0, so minus 1. So we get here 1 is equal to a into 1. A is here 1 upon 3. 1 upon 3 into 1, that is 1 upon 3. And here c into minus 1, it is minus c. And therefore we get here, carry this minus c to left side, we get c is equal to this 1 upon 3, and carry this plus 1 to right side. So we get here c is equal to 1 minus 3 into 1, that is 3, divided by 3. And therefore c is equal to 1 minus 3, that is minus 2 upon 3. 1 minus 3, that means 3 minus 1, it is 2, and sign of 3 is minus, so minus 2 upon 3. In this way we get here second unknown c. Now we have to find b. For that purpose here we take x is equal to, we have to take here 0 and 1, so now take x is equal to minus 1. So put here, put x is equal to minus 1. So we get 1 is equal to, this 1 is equal to a into x square, means minus 1 square, that is 1 minus 1 plus 1, 1 minus 1 plus 1, because minus 1 square is plus 1, and x, that is minus 1 plus 1, plus in bracket b into x, x is here minus 1, so b into minus 1, it is minus b, plus c, and x minus 1, x is here minus 1 and minus 1. Get it? So we get here 1 is equal to, this minus 1 plus 1 get cancelled, a into 1, a into 1, that is a, and put the value of a as 1 upon 3, so 1 upon 3, plus, and minus, this minus b, b is here, we have to find b, so minus b into this 2, so twice b, this minus 1 into minus 1, that is minus 2, minus 2 into minus b, that is plus twice b, and minus 2 into c, it is minus twice c. See here, minus 1, minus 2, minus 2 into minus b, that is plus 2b, minus 2 into c, minus 2c. Now put the value of here c. So 1 is equal to this 1 upon 3 plus twice b minus 2, and c is here minus 2 upon 3. C is here minus 2 upon 3. So 1 is equal to 1 upon 3 plus twice b, this minus minus plus, so plus 4 upon 3. So we get 1 is equal to, now here 1 upon 3 and plus 4 upon 3, denominator is same 3. So we add numerators 1 plus 4, that is 5. So 5 upon 3 plus twice b. Now carry this 5 upon 3 to left side, so 1 minus 5 upon 3 is equal to twice b. That is 3 into 1, 3 minus 5, 3 minus 5 minus 2 upon 3 is equal to twice b. Now cancel this 2. So we get here minus 1 upon 3 is equal to b. So b is equal to minus 1 upon 3. So in this way we get here unknowns a, b, c. Now we put these values of a, b, c in the required integral, in this integral. So this proper rational function we replace by this, by substituting the values of a, b, c, and therefore we write here required integral is, therefore required integral I is equal to integration of a upon x minus 1. A is here 1 upon 3. So 1 upon 3 upon x minus 1. Then plus bx. B is here minus 1 upon 3 into x plus c. And c is here minus 2 upon 3. Minus 2 upon 3. And divided by denominator as x square plus x plus 1. And dx. So it is equal to I is equal to integration, we separate the integration and take this constant outside the integral. So 1 upon 3 into integration of 1 upon x minus 1 dx. Now here plus, and this minus 1 upon 3 and this minus 1 upon 3 take common. So minus 1 upon 3 into integration of, here now x and plus 2. Here this become plus 2 divided by x square plus x and plus 1 dx. Now observe here second integral. In the denominator there is x square plus x plus 1. If we take the derivative of this, we get numerator. Derivative of x square is twice x. So we multiply by 2 here. Derivative of x is 1. We adjust here 1. So we get here I is equal to this 1 upon 3. We take this integration, but we take simultaneously all the integration. So integration of 1 upon x minus 1 dx. Here minus 1 upon 3 into multiply by 2. So 2x plus 2 into 2 4. We multiply by 2 in the numerator. So here divide by 2. And denominator is here x square plus x plus 1 dx. So I is equal to here 1 upon 3 as it is integration of 1 upon x minus 1 dx. Now here it is 1 by 6 integration of the derivative of denominator is twice x plus 1. So here twice x is present and we write this plus 4 as plus 1 and plus 3 divided by this x square plus x plus 1 dx. And now here we consider this 2x plus 1 as one part and plus 3 another part, and divide separately and take the separate integration. And so we get here I is equal to 1 upon 3 integration of 1 upon x minus 1 dx. This minus 1 upon 6 into integration of twice x plus 1 upon x square plus x plus 1 dx into this minus 1 upon 6 into integration of 3 upon this. So we take the here 3 and upon this x square plus x plus 1, x square plus x plus 1 dx. And now here I is equal to 1 upon 3 into integration of 1 upon x minus 1 dx. Here minus 1 upon 6, and now here we use the corollary, that is integration of f dash of x upon f of x dx, that is equal to log of f of x. But here we have to complete the square, x square plus x plus 1. We have to complete here square. So how complete? See here integration of this twice x plus 1 upon here x square plus x plus 1 dx, and minus here 1 upon 6 into this constant 3 and integration of 1 upon here x square plus x and this plus 1, this plus 1. And now here we add 1/2 into coefficient of x, that is 1/2 into 1 and its square, 1/2 into 1, 1/2, its square 1 by 4. So we add here plus 1 by 4 and here minus 1 by 4 and dx. And so this is equal to I is equal to 1 upon 3 into integration of 1 upon x minus 1 dx minus 1 upon 6 into integration of twice x plus 1 upon this x square plus x plus 1 dx, and this 3 1s are 3, 3 2s are 6, that is 1/2, and integration of 1 upon this x square plus x plus 1 by 4. It is the complete square of square root of x square is x, middle sign is plus, and square root of 1 by 4 is 1/2 bracket square. Now take the addition of this, 1 into 4, 4, 4 minus 1, that is 3, 3 upon 4. Here it is 3 upon 4, we write it as root 3 upon 2 bracket square dx. And now here take integration all of. Here we use the formula of integration of 1 upon x square plus a square, that is equal to 1 upon a into tan inverse of x upon a. And therefore I is equal to 1 upon 3 into this log of x minus 1. Here it is minus 1 by 6 into log of denominator. Denominator here x square plus x plus 1. Get it? Now here minus 1 half as it is, and integration of 1 upon x square plus a square, it is equal to 1 upon a. 1 upon a is here root 3 divided by 2 into tan inverse of x. X is here x plus 1 half divided by a root 3 upon 2 plus constant of integration. Now here final step we write required integral I is equal to 1 upon 3 into log of x minus 1. Log of x minus 1. This 1 upon 3 into log of x minus 1 minus 1 by 6 into log of minus 1 by 6 into log of x square plus x plus 1, and this third term we write here minus this 2 and 2 get cancelled, this 2 and 2 get cancelled, so 1 into 1, 1 upon root 3, 1 upon root 3 into tan inverse of, we multiply by 2 to numerator and also in the denominator, so 2 into x 2x plus 2 into 1 up to 2 get cancelled, so 2x plus 1, 2x plus 1, and divided by 2 into root 3 by 2, 2 get cancelled, so it is divided by root 3 and plus constant of integration. This is the final solution. So take the screenshot of this. So in this way we completed here 16th problem. Now we will see here 17th problem. 17th problem here, integration of 3 sin x minus 2, 3 sin x minus 2 into cos x upon 5 minus 4 sin x, 5 minus 4 sin x minus cos square x dx. 3 sin x minus 2 into cos x upon 5 minus 4 sin x minus cos square x dx. This is the 17th problem. We call this as I. So I is equal to given problem. Now see here in the given problem there are trigonometric functions sin x and cos x. When trigonometric functions we use the formulae firstly and then take the substitution method. So here we use formula for cos square x as 1 minus sin square x. So this is equal to integration of 3 sin x minus 2 into cos x as it is divided by 5 minus 4 sin x minus, and cos square x is 1 minus sin square x using the first fundamental identity. And now see here, if we take the substitution sin x as a t, we get derivative of sin x as cos x. So cos x dx become dt. So put here, sin x is equal to t, and therefore differentiate this with respect to x, we get derivative of sin x as cos x is equal to right hand side is dt upon dx, carry that dx, so cos x dx is equal to dt. So this I is equal to integration of 3, put sin x as a t, so 3t minus 2 and cos x dx as dt divided by 5 minus 4 sin x is t minus 1 minus sin x is t. So it is t square and cos x dx is dt. So we write this as integration of 3t minus 2 divided by 5 minus 4t, this minus 1 minus minus plus t square dt. So this is equal to integration of 3t minus 2, this 3t minus 2. Now write here t square firstly, t square, then here minus 4t and plus 5 minus 1. that is 4 dt. So it is equal to integration of 3t minus 2 divided by, observe the denominator, t square minus 4t plus 4. This is the complete square of square root of t square is t, middle sign minus, and square root of 4 is 2. So that is t minus 2 bracket square. T minus 2 bracket square. See, t minus 2 bracket square, t square minus 2 into t into 2 minus 4t plus 2 square as a 4. And now here observe denominator, this is a rational function, proper rational function, but in the denominator linear factor is repeated. So this is of the second type. So consider this. So let 3t minus 2 divided by t minus 2 bracket square, t minus 2 bracket square is equal to, we write this as a upon t minus 2 plus b upon t minus 2 bracket square. And therefore we get here, we take the addition of the right hand side. So here a into t minus 2, because LCM is t minus 2 bracket square, so we multiply by t minus 2 to numerator and denominator. So a into t minus 2 plus here b, because here t minus 2 bracket square is present, and on the left hand side it is 3t minus 2, both the denominators we cancel here. Now here we have to find the value of a and b. So put here first factor, that is put here t minus 2 is equal to 0, that is t is equal to 2, carry this 2, so t is equal to 2, and therefore we get here 3 into 2 that is 6 minus 2 is equal to a into t minus 2 is 0, so a into 0 plus b. So we get here 6 minus 2 as a 4, so b is equal to 4. We get b is equal to 4, this b, and 6 minus 2 4. Now we have to find another constant, that is a, and to find a we take here t is equal to suppose 0. So t put t is equal to 0. We may take another real number, t is equal to 1 or minus 1, 2 or minus 2, but take here t is equal to 0. So 3 into 0, therefore we get 3 into 0, that is 0 minus 2. So minus 2 is equal to a, t is 0, so 0 minus 2 it is minus 2, and plus b. Now put the value of b. So minus 2 is equal to minus 2a, and b is here plus 4. Carry this 4. So we get here plus 4 become minus. So minus 2 minus 4 is equal to minus 2a. Minus 2 minus 4 minus 6 is equal to minus 2a. And therefore a is equal to, this minus become plus, a is equal to 6 upon 2. 6 upon 2 that is 3. 2 3s are 6, 6 upon 2. So in this way we get a as a 4, and a as 3 and b as 4. Now we put the values of a and b in this equation and take the integration. Therefore required integral is, I is equal to, we replace this rational function 3t minus 2 upon t minus 2 bracket square by this, and putting the values of a and b, that is a is here 3, so 3 upon t minus 2, 3 upon t minus 2 plus b is here 4, so 4 upon t minus 2 bracket square and dt. And now take the separate integration. So I is equal to, take these 3 constant outside the integral, 1 upon t minus 2 dt plus 4 constant outside the integral, integration of 1 upon t minus 2 bracket square dt. And now here we know here integration of 1 upon t, that is equal to log of t. So 3 into log of t t means here t minus 2. If we take the derivative of t minus 2, again it is 1. So divide by 1, there is no need to divide by 1. Plus this 4 as it is constant, and integration of 1 upon t minus 2 bracket square. We know that d by dt of 1 upon t, derivative of 1 upon t, that is equal to minus 1 upon t square. We know this. And therefore here integration of this 1 upon t square, integration of 1 upon t square dt is equal to, carry this minus sign here, so minus 1 upon t. So integration of 1 upon t square dt, that is equal to minus 1 upon t. So integration of 1 upon t square. So what is now here integration? Minus 1 upon t, but in place of t there is t minus 2. T minus 2 and plus constant of integration. So here final step, we replace the value of t. Here t is sin x. T is here sin x. So we put the value of t as a sin x, and so it is equal to 3 into log of sin x minus 2, plus minus become minus 4 into 1, that is 4 upon t minus 2, that is sin x minus 2 plus constant of integration. This is the final solution. We highlight this solution like this. Take the screenshot. So in this way we completed here 17th problem. Now here we will see 19th problem, and then we take 18th problem. So 19th problem here, 19th problem, integration of 1 upon 2 sin x plus sin of 2x, 1 upon 2 sin x plus sin of 2x dx. Again here trigonometric functions. So here we have to use the formula for sin of 2x firstly. Sin of 2x. What is the formula for sin of 2x? That is 2 times sin x cos x. So we call this as I. So I is equal to integration of 1 upon 2 times sin x plus sin of 2x dx. We put the formula for this sin of 2x. So this is equal to integration of 1 upon 2 sin x and plus sin of 2x is 2 times sin x cos x dx. Get it? Now here observe the denominator. Here 2 sin x, here 2 sin x, take 2 sin x common. Take here 2 sin x common. So it is equal to integration of 1 upon 2 sin x in the bracket here 1 plus here cos x dx. So 1 upon here, 1 upon this 2 sin x common, 2 sin x in the bracket 1 plus cos x dx. Now this 2 is constant, and observe here we have to use now substitution method. We put bracket as t, in the bracket there is cos x, so put here cos x is equal to t. When we take the cos x as t, its derivative is sin x minus sin x. So we have to adjust here sin x in the numerator and denominator. So we multiply by numerator by sin x. So 1 into sin x as a sin x and divided by sin x into sin x, that is sin square x, and this 1 plus cos x as it is dx. And this 2 constant we write here 1 upon 2. And now here put sin square x as 1 minus cos square x. So this is equal to 1/2 integration of sin x upon, we put sin square x as 1 minus cos square x into 1 plus cos x dx. Again factor this 1 minus cos square x using the formula a square minus b square. Here 1 means 1 square. So 1 square minus cos square x, that is 1 minus cos x into 1 plus cos x. and here also 1 plus cos x. So we write here 1/2 integration of this sin x as it is, and here factors of this 1 minus cos square x is 1 minus cos x into 1 plus cos x, get it, and into 1 plus cos x. So 1 plus cos x repeats, so we write here 1 plus cos x bracket square and dx. And now use here substitution method. Put here cos x as a t. So put cos x is equal to t. Derivative of cos x is minus sin x is equal to dt upon dx. Upon dx carry. So we get here sin x dx is equal to minus dt. And therefore this I becomes I is equal to constant this 1/2 as it is, and sin x dx that is equal to minus dt. We write here minus dt, and here in the numerator 1, and in denominator 1 minus cos x is t. Cos x is t, so 1 minus t, and here 1 plus cos x bracket square. So 1 plus cos x means t and bracket square. And so we write this I is equal to, take this minus sign outside the integral, so minus 1/2 integration of 1 upon 1 minus t into 1 plus t bracket square dt. Now see here denominator, this 1 plus t repeats, so we use here second type, that is repetition of linear factor. So we consider this, so let here 1 upon this 1 minus t into 1 plus t bracket square, we write this as a upon first factor, that is 1 minus t, plus b upon 1 plus t. 1 plus t repeats, so firstly write b upon 1 plus t and plus c upon 1 plus t bracket square. And now take the addition, make the denominator of every term as 1 minus t into 1 plus t bracket square. So here we write 1 is equal to a, here we have to multiply by 1 plus t square to numerator and denominator. So a into 1 plus t square, 1 plus t bracket square, plus b, here we have to multiply by 1 minus t and also 1 plus t, 1 minus t into 1 plus t, and plus c, and here multiply by 1 minus t to numerator and denominator. And now we want to find the value of a, b, c. So put here 1 minus t is equal to 0. Put 1 minus t is equal to 0, that is t is equal to 1. Carry this minus t. So t is equal to 1 in this equation. And therefore 1 is equal to a, 1 plus t is here 1. So 1 plus 1, that is 2. So 2 square. Plus b, here 1 minus t. So 1 minus t is 0, so it becomes 0. Plus c, 1 minus t is 0, so c into 0. And now here 2 square is 4, and carry that 4. So a is equal to 1 upon 4. We get here a is equal to 1 upon 4. 2 square 4, carry that 4, we get a as 1 upon 4. Now we put here second factor. Put here second factor means 1 plus t is equal to 0. That is t is equal to, carry this 1, t is equal to minus 1 in this equation. And therefore 1 is equal to a, and here 1 plus t 0, so a into 0, plus b, here also 1 plus t, so 1 plus t is 0, so 0, so b into 0, plus c, and here 1 minus t, so 1 minus and t is minus 1, so 1 plus 1, that is 2. 1 minus and minus 1, that minus become plus, and therefore we get here c is equal to, this is 0, so twice c, so c is equal to 1/2. We get c as 1/2. In this way we find here a and c. We have to find b. Here we put t is equal to 1, t is equal to minus 1. Now put t is equal to 0. So put here t is equal to 0 by randomly. We take this 0 randomly. We may take 2, minus 2, etc. So when we take t as a 0, what happens here? So 1 is equal to a 1 plus 0 means 1 square, and plus b here 1 minus 0, 1 plus 0, that is 1, so b here, plus c here 1 minus 0, that is 1. So a plus b plus c is equal to 1. We get the equation as a plus b plus c is equal to 1. Now put the values of a and c. So we get here 1 is equal to, value of a is 1 by 4 plus value of c is 1 half, b as it is, and c is 1 half. So here we take 1 plus this 1 by 4 plus 1 half. Here denominator we have to make 4. So multiply by 2. So 2 into 1, 2 by 4, and 2 plus 1, that is 3. So 3 by 4 plus b. 3 by 4 plus b. And therefore b is equal to 1 and minus this 3 by 4. And 4 into 1, 4. 4 minus 3. That is 1. 1 upon 4. So b is equal to 1 upon 4. We get b as 1 upon 4. Now put these values of a, b, c. We put the values of a, b, c in the required integral, and therefore required integral becomes, so required integral I is equal to this I is equal to minus 1 half, as it is integration of, we replace this rational function by this, and we put here a as 1 by 4 upon this 1 minus t, plus b is here 1 by 4 upon here 1 plus t, plus c is here 1 half upon here 1 plus t bracket square, 1 plus t bracket square, and dt. Now take the separate integration with this constant minus 1 half. So I is equal to minus 1 half into this 1 by 4. So it is 8. 2 into 4, 8. Minus 1 by 8, integration of 1 upon 1 minus t dt. Now this minus 1 half and plus 1 by 4. Here also minus 1 by 8. Integration of 1 upon 1 plus t dt. This minus 1 half into plus 1 half, that is minus 1 by 4. This minus 1 half and this 1 half. So minus 1 by 4. Integration of 1 upon 1 plus t bracket square dt. And now take here integration. All are the standard formulas. Integration of 1 upon t is log of t. Here integration of 1 upon t square, that is equal to minus 1 upon t. And so we get here I is equal to minus 1 upon 8 into log of 1 minus t divided by derivative of this 1 minus t. Derivative of 1 minus t is minus 1. So divided by minus 1. Minus here 1 upon 8. Minus 1 upon 8 into log of 1 plus t. Derivative of 1 plus t is 1. Minus here 1 upon 4. And integration of this is the derivative of minus 1 upon t. In place of t we write 1 plus t and plus constant of integration. So final solution is here I is equal to minus minus become plus. So 1 upon 8 into log of 1 minus, put the value of t. T is here cos x. T is here cos x. So 1 minus cos x minus 1 upon 8 into log of 1 plus t is cos x, and here minus minus become plus. 1 into 1, 1 upon 4 in the bracket, 4 in the bracket, 1 plus t is here cos x and plus constant of integration. This is the final solution. Take the screenshot. So in this way we have completed here 19th problem. Now here we will see 18th problem. 18th problem is similar to this problem, 19th problem. So 18th problem, integration of 1 upon sin x plus sin of 2x. 1 upon sin x plus sin of 2x dx. Call this as I. So I is equal to integration of 1 upon sin x plus sin 2x dx. Now we put the value of sin of 2x. In the previous problem we have here integration of 1 upon 2 sin x plus sin of 2x, and here sin x plus sin of 2x. Okay, so this is equal to integration of 1 upon this sin x as it is plus sin of 2x is 2 times sin x cos x dx. Here take sin x common, so integration of 1 upon sin x in the bracket here 1 plus 2 cos x and dx. Now if we take the derivative of cos x, it is minus sin x, so we multiply numerator and denominator by sin x, and so we get here 1 into sin x, that is equal to sin x divided by sin x into sin x, that is sin square x, in the bracket 1 plus 2 cos x dx. Now put here put sin square x as, so this is equal to integration of sin x and sin square x as 1 minus cos square x into 1 plus 2 cos x dx. Again factor this, so we get here integration of sin x upon this 1 minus cos square x, that is a square minus b square. A minus b means 1 minus cos x, a plus b means 1 plus cos x, and this 1 plus 2 cos x as it is dx. And now we use here substitution method, put here cos x as a t, so put cos x is equal to t, and derivative of cos x is minus sin x, so minus sin x dx, that is equal to dt, and therefore we get here sin x dx is equal to carry this minus sign, so minus dt. And therefore this integral I becomes, I is equal to integration of sin x dx is minus dt, sin x dx is minus dt, in the numerator 1, and 1 minus cos x is t, so 1 minus t, then 1 plus t, and here 1 plus twice t, 1 plus twice t. Take minus sign outside the integral, so I is equal to minus integration of 1 upon 1 minus t into 1 plus t into 1 plus twice t dt. And now observe this rational function in the denominator, there are 3 linear factors. And now consider this, let here 1 upon this 1 minus t, 1 plus t, and this 1 plus twice t, it is equal to a upon first factor, that is 1 minus t, plus b upon second factor, that is 1 plus t, and plus c upon third factor, that is 1 plus twice t. Take the addition of the right hand side, and so we get here 1 is equal to, this numerator 1 is equal to a into denominators of other two, that is a into 1 plus t into 1 plus twice t, plus b into this denominator 1 minus t into this denominator 1 plus twice t, plus c, and denominators 1 minus t into 1 plus t. And now we find the values of a, b, c. So put here first factor, that is put 1 minus t is equal to 0, that is t is equal to 1, carry this t, so t is equal to 1, and therefore we get here 1 is equal to a into t is 1, 1 plus 1, that is 2, and here 1 plus 2, that is 3, because t is 1, 1 into 2, 2, 2 plus 1, 3, plus b, here 1 minus t 0, so it is 0, plus here c, 1 minus t 0, so 0, and 2 into 3, 6, 6 a plus 0 plus 0, so carry this 6, we get a is equal to 1 upon 6, we get here a as a 1 upon 6, and now we find next unknown b and c by substituting So put here second factor 1 plus t. So put here 1 plus t is equal to 0, that is t is equal to minus 1. And therefore we get 1 is equal to a into here 1 plus t, so a into 0 plus b, and 1 minus t is minus 1, 1 minus minus 1, that is 1 plus 1, 2, so b into 2, here 1 plus twice t is minus 1, so 1 minus 2, 1 minus 2, minus 1, plus c into 0, so here it is 2 minus 1, minus 2b is equal to 1, and therefore b is equal to minus 1 upon 2. We get here b is equal to minus 1 upon 2. This 0 and this 0, and this is minus twice b is equal to 1. Carry minus 2. So b is equal to minus 1/2. Now put here third factor that is 1 plus twice t. 1 plus twice t is equal to 0. That is t here. Carry this 1, it is minus 1, then carry 2, minus 1/2. And therefore 1 is equal to a, here 1 plus 2t, so it is 0, so a into 0, plus b, here also 1 plus 2t, so b into 0, plus c in the bracket 1 minus t, so 1 minus, and this minus 1/2, so plus 1/2, and 1 plus t, that is 1, and t is minus 1/2, so minus 1/2. So we get here 1 is equal to this 0, 0. So C, this 1 plus 1/2, that is 3 by 2. 2 into 1, 2 plus 1, 3, 3 by 2. And 1 minus 1/2, 1 minus half. So it is half. And so we get here 1 is equal to C, 3 into 1, that is 3, divided by 2 into 2, 4. And therefore C, we get C as 1 into 4, that is 4, and upon this 3. So in this way we get C as a 4 upon 3. And now we put the values of A, B, C for this rational function. So required integral is, required integral I becomes, I is equal to this minus sign and integration of, and we replace this rational function by this right hand side by a, putting a as 1 by 6. So 1 by 6 divided by 1 minus t, plus b, b here minus 1/2, minus 1/2 divided by 1 plus t, 1 plus t, plus c, c here 4 by 3, 4 by 3 divided by 1 plus twice t, 1 plus twice t dt. And now take the separate integration, take the constant outside the integral, and with this minus sign. So I is equal to minus 1 upon 6 integration of 1 upon 1 minus t dt. This minus sign and this minus sign become plus, so plus 1/2 integration of 1 upon 1 plus t dt. This minus sign and this plus become minus, and this 4 upon 3 integration of 1 upon 1 plus twice t dt. So we get here I is equal to this minus 1 upon 6 integration of 1 upon t, that is log of t. So log of t, in place of t there is 1 minus t, so take the derivative of 1 minus t, it is minus 1, so divided by minus 1. Now here plus 1/2, here also integration of 1 upon t, that is equal to log of t, t is here 1 plus t, t is here 1 plus t, and derivative of 1 plus t is 1, so there is no need to write 1 in the denominator, minus here 4 upon 3 log of, here derivative of 1 upon t, 1 plus twice t, in place of t there is 1 plus twice t, so take the derivative of 1 plus twice t, that is 2, so divided by 2, and plus constant of integration. Now here 2 1s are 2, 2 2s are 4, and so we get here I is equal to, this minus and minus become plus, so it is equal to 1 upon 6 log of, and put the value of t, that is 1 minus t is here cos x, so 1 minus cos x plus 1/2 into log of 1 plus t, t is here cos x, and minus here 2 upon 3 into log of 1 plus 2 and t is here cos x and plus constant of integration. This is the final solution. We highlight this solution like this and take the screenshot. So in this way we completed here, in this lecture we have completed here 4 problems, and the last 4 problems we will see in the next video lecture. Take here screenshot. Thank you.